Hey, hi everyone. So for this video, I will discuss the continuous probability distribution. So we have already discussed the discrete probability distributions and how do we determine the probability of an event occurring. Now, we will move on with the discrete form of probability distribution. More specifically, we'll focus on normal distribution as an example for continuous probability distribution. So a continuous random variable is a variable that can assume any value on a continuum. No? So basically, if you have a continuous random variable, it can uh, represent a value with a number that have a continuous space. No, so what I mean by that, actually, the best explanation is it it can explain decimal numbers. Ano, everything that can be represented with decimal numbers are continuous. So the thickness of an item, time required to complete a task in this in continuous, no? Temperature of a solution, height, and so on. So it depends on the precision and accuracy of your measurements, how closely it will resemble your probability. Now, again, an example of continuous probability distribution will be the normal distribution. Now, it is just a bell-shaped curve, yung ating normal distribution. And what are the important properties of a normal distribution curve? So the first one is the mean, median, and mode is basically in the middle of your distribution. You know, and it is symmetrical for both sides. No, so whatever the area is in here, no, whatever area is this, then the area in here in this portion, if we divide this by half, then it will be equal. Now, the location of your data, actually, we'll discuss this later, but we can locate the data by the mean, no? So usually our mean is our reference, no? And another determination of location is also the standard deviation. So this is the property of your data. You have a mean, you have your standard deviation, and based on that two parameters, you can have some predictions regarding the probability of an event occurring. So this shape here actually is a horizontal asymptote, ano? And it will reach from it reaches from negative infinity from this side and positive infinity to this side. So usually it is a very very small number if it is continuing, if it continues to the negative and positive infinity spectrum. Now, for the mathematical equation that represents this probability distribution function, or sometimes it is also called the probability density function, is this formula. So, if you want to use this as a way, no, actually, you don't have to memorize. You don't have to use a table. You can just memorize this formula, and you will have a representation of the probability density function. Okay, but anyways, what does this tell us? Now, so if you have your mean and your x, no? So x is your random variable, and then your standard deviation, then you can find the probability of an event occurring depending. Well, we will discuss later the details about it being less than this value, greater than this value, or within this value. So I hope you are already familiar with these variables here. So we have E, we have pi, we have mu, the population mean, we have sigma, which is the population standard deviation, and x is the value of your continuous variable. Now, for normal probability density functions, we have a comparison of two different normal distribution. We have the mean and the standard deviation. So we can customize our normal distribution for based on the mean and the standard deviation. So if you change the mean, what happens is the location of your this curve here. So it can transverse now from left to right, depending on your mean. If your mean is lower, then it will go to the left. If your mean is higher, it will go to the right. Same goes with standard deviation, but in a different manner. No, if you have a low standard deviation, the spread is much lower, meaning it will be a higher peak. No, it seems to be at a higher peak. And then for greater standard deviation, it will be much more spread out. No, so a smaller mountain will represent this curve if you have a lower standard deviation. Now, we are already familiar with this estimation, which basically means that if you have a normal distribution curve, and if you want to find the area, no, within one standard deviation. So within one standard deviation, meaning mean plus one standard deviation, and then mean minus one standard deviation. This will be just 68% of your probability. If you have two means, no, within two mean, sorry, within two standard deviations, that will be 95%, no, and then so on. So three standard deviations will be 99.7%. Okay, so what does that mean? So if you have, let's say, for example, lang, no, to give you context here, is let's say, what is the probability that that your height your height is let's say 5 feet to 2 inches. Okay, so if we know that, let's say for example lang, no, although I cannot guarantee that this is correct if you compute this, let's say your standard uh hindi, dapat pala ito ano, no, it should be within the data, sorry, is within pala, no, is within let's say 5 feet 2 inches and 5 feet let's say 6 inches, for example lang naman to, no. So this is your range, no? So meaning parang siguro 5 feet 6, sorry, 5 feet 2 inches to, and then 5 feet 6 inches to. So if let's say your mean, no, for example, is your mean is 5 feet 2, sorry, 4, is that correct? Should be 5, right? Hindi, 4 nga. 2, should be 2, no? Sorry, 4 pala, sorry. So if you're trying to find what is the probability that your height will be this, assuming that your standard deviation, your population mean is equal to 2, no? 2 inches, meaning the distance between this is 2 inches, then you can have this estimate that there is a 68% chance that that you will be within this height. Okay, so that is the first, no, motivation for studying normal distribution or the rational. Okay, so any normal distribution can be transformed into the standard normal distribution z. Need to transform x to z, and so on. So there is a thing called the standard normal distribution. What this basically means is that your data might be, you know, based on our example, is let's say this is 5, no, let's say this is 5 feet 2 inches again, and then this is 5 feet 4, sorry, 6, sorry, ito pala 4, no? This is 5 feet 2, 5 feet 6, yeah. So basically, if this is your normal distribution, you can make this a standard normal distribution, wherein instead of having these values, you will have a value of something like 0, 1, and -1. So instead of x, we can transform this into the z variable. So in terms of the z variable, note this transformation from this x variable to the z variable will lead us to the standard normal distribution. So bakit ba binabago pa yan? Because our tables, kasi po yung tables natin is based on the standard normal distribution in terms of the z-score. Okay? So we will have a better idea once we get into an example. Okay? So translate x to the standard normal distribution by subtracting the mean and dividing by the standard deviation. So the transformation goes like this. So you have to, given your continuous random variable x, after finding the population mean and the population standard deviation, you can transform into its z-score, what we call the z-score. Okay, and then after that, you can just use the table to find the probability at that specific z-score. Okay, so again, what are the properties of standard normal distribution? So the properties of standard normal distribution is that its mean is 0 and its standard deviation is 1. Ano? So values above this, the mean positive z values, values below have the mean z values. So if you have, let's say, a curve that looks like this, a normal distribution curve. So if this is your standard normal distribution, so your middle or your mean, which is also your median and also your mode, then the z-score will be 0. So if you have the z-score here to the left, it will be negative, okay? And if you have a z-score here to the right, this will be positive. Okay, so that is one property that you should remember. Okay, so let's have an example now. So find the probability that z is greater than 2.2. So what does that mean? So if you have a z-score, no, which is 2.2, what is the probability that it is greater than? No, so this is probably the standard normal distribution, no, since the only given is z and you have 2.2, no. So if you have again a standard normal distribution, this z-score at the middle is 0, and then z is equal to 2.2 means that if it is positive, then it is somewhere here. So z is equal to 2.2. Now, what we're trying to find is greater than, so greater than 2.2, and therefore what we're trying to find is this probability. So we're talking about areas, no? So the area here will be the probability that z is greater than or actually equal to, no, it will be the same for greater than or greater than or equal to 2.2. Okay, so how do we find that now? No, so let's take a look at our standard normal distribution table. Ano? So let's get a brief on what does this table say. What does this? How do we use this table? So it depends on your table. Actually, there are different tables that have different ways of getting the probability. But for this example, no, you can see here that the tabulated area probability is starting from this negative, no, negative infinity up to this z-score here. So if you find or if you're trying to find the probability and then you have a given z, what probability or area you will find is this left portion, diba? So the left portion here will be what you will find. So what we're trying to find here is on the rightward side of our graph. So how do we find that now? So I didn't mention this, but the total area, no, total area of a normal distribution curve, which is also the total probability, okay, is equal to 1, no, or 100%. Okay, so that's one. For this one, how do we do this? No? We have 2.2. So z is equal to 2.2. So to find 2.2, we just want to look first in this column, no? So this, since this is 2.2, okay, we want to find 2.2, okay? So depending if this is 2.21, 2.23, and so on, since this is just 2.2, we just add this 2.2 plus this column here plus 0. So therefore, this will be your entry. So we have 98.61. So the probability exactly, no, that z is equal to, actually this should be 0, no. So to date this, the z here is less than or equal to 2.2, okay, which is equal to 0.9861, right? So what data does this mean, no? So this means that if you have a z-score here of 2.2, it's a lot of 2, no? Then the area here is your 0.981. Ngayon, what we're trying to find again is this. So therefore, if the total probability is 100%, then this is the remainder, no, or the leftover. So we have the probability of z greater than, no, this is what we're trying to find, greater than z 2.2. That is equal to the whole, no, so everything else minus, no, this. Okay, so minus 0.9861. So this is equal to 9, we have 3, and then 2, and then 0.0. Yeah, that's correct. Let's try. So 1 minus 0.9861. Oh, sorry, 139 pala, no? Okay. Okay. Or you can write this as well in its percentage form. So we have 1.39%. So there's this probability that the z value will be greater than 2.2. Okay, so so this is how we visualize this problem. Now find the area of the curve between 0.8 and 2.4. So if we have this problem again, we have the z-score, we have the z-score. So the best way to do this is to just visualize the problem first. So we have this, oh, we have this curve. So the z here is 0. And then so we have here z is equal to 0.8. And then another z here, z is equal to 2.4. So what we're trying to find is in between, meaning the area here we're looking for is this in between of this z-scores. So how do we now find that? Ano? So based on our table, we can only get when we want to get the z-score or the probability for z is equal to 0.8, we will have something like this. Okay? So this is what we will get, no? And then for z is equal to 2.4. So if this is 2.4, this is what we will get in the table. Now, how do we determine, okay, this area? What we can do, no, as you can see, we can subtract this 2, di ba? If we subtract this 2, we can get this. So basically, we have to subtract 0.8. So this is negative and this is positive. So to subtract the probability of this into this. So therefore, the probability that your z-score is in between. So if this is in between, so z is greater than or equal to 0.8 and z is less than or equal to 2.4. Okay, is equal to the difference between the probability. So probability that z is less than or equal to 0.8, and then actually this should be the other side. Sorry, this is the greater one. No? This is positive. So kumbaga we subtracted each other. So this will be p z is greater than or equal to 2.4. Actually less than pala, no? So minus p of z is less than or equal to 0.8. So to find this, we can again use the table. So we have 0.8. So 0.8 here. So 0.8 plus 0.0. So 0.7881. 0.7881. And then for 2.4, we have 9918. Therefore, the probability here will be, what is it? Yeah. So 0.9918 minus 0.7881. So the value is 2037. So 0.2037. So this will be your probability. So this area right here is expressed by this value. So 20% or 20.37% of the total area of normal curve. Okay. So find the area of the curve between z negative 2.33 and 1.65. Okay, so another one, no? So we have another problem here. So z is equal to negative 233 and z is equal to 1.65. So again, the dead middle is 0. And then the positive, we have 1.65, so somewhere here. And then negative side, we have z is equal to negative 2.33. So the total area we're trying to find is in between. So this is the area we're trying to find, which is the probability. So in between, no? So this should be z is greater than or equal to negative 2.33, but less than or equal to 1.65. So to find this area again, we have the subtraction of two values. So we can find z is equal to 1.65, find this area, and also this area. Okay, z is, z is negative 2.33. So this. So to find the area, we can subtract, no? Subtract these two areas to find the difference in between these two areas. So again, this will be equal to, okay, this will be equal to the probability that z is less than or equal to 1.65 minus the probability that c is less than or equal to negative 2.33. Okay, so let's try that out again. So we have 1.65. So we only have 1.6 here. So we have to check the columns, which has the 5. So 1.6 plus 0.05, we got 1.65. So therefore, we have 0.9505, 0.9505. And then the other one, we have negative 2.33. So sir, how do we do this? We don't have a negative here. So the negative here is actually not here, right? So how do we do that now? No? Wala pala dito, no? Start siya dito. Medyo mahirap pala 'to 'no. Actually, I'm not used to using this kind of probability distribution. So, how do we now get negative 2.33? So, the negative 2.33 here is still this one, no? We can use this. So, we have negative 2.33. So, 2.3 and 33. So, we have this entry, but actually, since the given here, the given here is the area here is only positive, no? So for z-score that is positive, this is your value for, what is the value nga? We have 9901. We have 9901, right? 9901 here, or 0.9901. And we know that if this bell curve is symmetrical, then therefore, what we have in the, actually, what we have in the, what do you call this? In the table is this as well, no? So this is equal to this, di ba? So therefore, the actual value of this is 1 minus 0.9901. So we have minus 1 minus 0.9901. So the value of this will be, where's my calculator? Wala. Okay, so this one. Okay, we can compute this, ano muna, no? This probability of negative 2.33. Just to see the numerical value. So we have 0.099. So we have 0.9505 and then minus 0.0099. So if you compute this, so we have this. So 0.9505 minus 0.0099. Then the value will be 9406. So 0.9406. Then this is also the same as 94.06%. Okay? I hope that's clear, no? So moving on, find the value of z if the area to the right is negative z is equal to 0.8212. So if the area of the right is negative z is equal to 0.8212. Okay, so let's visualize this again. We're trying to find down the z-score, no? So to find the z-score, how do we do that? No? So we have negative z. So z is negative, we do not know, no? Negative of what? So this is on the left portion. And we have a given area. So the area given here, no? The area is 0.8212 because the right z is 0.8212. How do we now find the z-score? So given the area, you want to now find the z-score. So how do we do this? Okay. So if you actually flip this around, no? If you flip this around, if this is negative, well, this is negative, right? If you flip this around, since we know that this is symmetrical, guys, so since we know that this is symmetrical, we can also say this, that the z is positive here, and the area that is given is, the area is 0.8212 still. So we can use the table, no? And find this value, and then we can find the z-score. That's basically it. So the z-score here, you can find 0.8281. Let's find 0.8281 ba yan? 8212. So we have 8212 here. Therefore, the answer is 0.92, right? 0.9 plus 0.2, 0.02. So we have 8212. Therefore, the z-score is 0.92. But not too fast, no? Since we flip this around, if we fix this again, no, to the other side, then this should be negative. Kasi nga, sabi niya to the right of negative z. No? So the answer should be negative 0.92. Okay? So I hope that's clear. So the experience of a certain government hospital showed that the distribution of the length of stay is maternity patient is normal with mean of 11.5 days and standard deviation of 2 days. What percentage of its patients stayed 9 days or less? Okay, so this is an example or application of normal distribution in a real world scenario. No? So if you want to estimate the probability of an event occurring, given your data, no, as your reference, then it is possible. No? So we have a mean of 11.5 days and a standard deviation of 2 days. Okay, so mu is equal to 11.5, sigma is 2. Now, the question here is, what percentage of its patients stayed 9 days or less? So we have here a random number, a random variable, a random variable of 9. That's basically it. So now, if you want to solve this, we want to first transform from x into z. So we will use the formula x is equal to, z is equal to, you have this, x minus mu over sigma, no? So the x is 9 minus mu, so we have 11.5, and then the sigma, sigma is 2, so the z-score here is negative, as you can see, which is, I'll just show you the computation. This is negative 1.25. Now, what we're trying to find is 9 days or less. So what does basically mean, if this is the normal distribution only, no, not the standard one, then the mean here is 11.5 days. And then you have a difference here of one standard deviation, which is, we have 9.5, okay, one standard deviation. But what we're trying to look for is the 9, no, x is equal to 9, which is this portion, which is the area. If this is less than, no, 9 days or less, then what we're trying to find is this area. Now, if you transform this into a standard normal distribution form, this should become, the mean should be 0, and the standard, or the z-score will be z is equal to negative 1.25. So what we're trying to look for is this area. So to find that area, we can use, just directly use the table. So we already have the z-score. So 1.2 and then 5, so 0.89. 0.8944. Although this is negative, no? So if this is negative, what you have to do is to use the complement function. So if the probability of z is less than 1.25 is equal to 0.8944, 99.44, then the probability that Z is less than negative 1.25 is 1 minus this 8944. So the answer should be 10.56 or 0.1056 or 10.56%. Okay, so the answer here is the probability of a patient staying in less than 9 days is 10%, assuming that your data says that on average 11.5 days and the spread of the data is 2 days. Okay. If a new method in nursing care is to be administered to the middle 95% of the group, how long should the patient stay to be included in the study? So what is this now? Okay. So in the middle of 95% of the study, what does that mean? You know? So basically 90% is your area, ano? So if this is your area, let's say this is 95%, then you have a z-score here that is symmetric. So this is just the negative portion and this is the positive portion. Now, how do we find this 95%? Ano? How is that? Okay? That is quite hard, no? Imagine. Mahirap pala dun sa ano natin, no? It is actually hard to use this table with this in mind. Anyways. Well, what we can do here, in here, is that instead of, we can subtract this by 0.5, everything here. And then, anyways, how do we find that? Sige, let me just divide this by 2 for now, no? If you divide 95% by 2, this is 47%, no? 0.5% or 0.475. 475. Ayan. Now, the area that I'm talking about is this. So this is 0.475. Now, with the table that we have, we know that, sorry, not this one. The table that we have, where's my highlighter? With the table that we have, we can know this portion, right? Everything here. So what we can do is we want to find the probability of the z-score that we do not know, which should be less than this. Yeah, let's just define something that the z-score is this. And then we have a total of 0.5 plus 0.475. So why did I add 0.5 here? So I divided this 95% into 0.475 so that I could get this portion, right? So this half of this 95%. But the table that we have gives us this total area, this yellow highlight here. So if you can remember, no, we know that the standard normal distribution is symmetric, meaning if you split this in the middle when z is equal to 0, then half of this area will be 50% or 0.5. So therefore, what we're looking for is 0.5 plus 0.475, which is 0.975. Okay? Diba? Is that correct? So therefore, we want to find the z-score z-score based on this probability. So the probability here that has the 975 is this. So we have 1.96. So this is 1.96. Therefore, what that means is that we have this standard normal distribution. We have z is equal to negative 1.96 here. Z is equal to 1.96 here. And this is your 95% or 95.95. Now, what we're looking for is how long should the patient stay to be included in the study. Therefore, we're trying to look for X here. So we have the Z value. We will now transform back to the value of the random variable, which is X. So we know that Z is equal to X minus mu and mu over sigma. So we can simplify this into Z sigma plus mu, diba, is equal to X. So X here is equal to, so should we use the positive or negative? We can use the positive first, no? And then I will define you what does the negative mean. So I'll just use the positive z-score, so 1.96. Sigma is 2. The mean is 11.5. Okay? So if you simplify this, the x variable will be what? I don't have a calculation. 1.96 times 2 plus 11.5. So 15.42. So we have 15.42. Now, this is just the outer boundary, meaning if you draw this again, kasi ito standard normal to, no? Kapag hindi standard normal or the not standard normal, so this is just the normal. I'll just draw this first, no? So this is the normal distribution in itself. So the mean here is 11.5, okay, days. And then you have 15.42, basically means 15.42 here. Okay? And then we want to also find the x value of the negative. So we have negative 1.96 and then 2 and then plus 11.5. That will be 7.58. I'm just not show you the calculation. So this will be 7.58 days. So the area around here is again 95%. So the range, no? The range that this will the patient will stay at 95%, no, of the time will be the range of 7.58 to 15.4. Okay, so I hope you learned something here. See you guys in class, and I will continue another video with hypothesis testing. So thank you guys.